All right, so we are multiplying here, and notice it's a binomial that is squared, so my hint to you was this is a 2 by 2 box. We're multiplying 3x squared minus 4y squared times itself. Okay, so I'm going to set up a 2 by 2 box. 3x squared and negative 4y squared goes across the top, and because of that square, I'm multiplying it times itself. So the same thing goes down the side. Keep in mind, when we multiply here, we are multiplying coefficients and adding powers. We are multiplying coefficients and adding powers. So when I multiply here, I get 9x to the fourth. When I multiply here, I get negative 12x squared y squared. When I multiply here, I get negative 12x squared y squared. And then when I multiply the last terms, negative times negative is a positive, and I add powers to get y to the fourth. Okay? Now, the middle terms here can be combined together. Why can they be combined together? They're alike because they both have an x squared y squared. And remember, when we're combining, we do not add powers. So when I combine here, I get negative 24, and we just keep the x squared y squared. I'm going to bring down my 9x to the fourth. I'm going to bring down my positive 16y to the fourth. And that's my answer. Yes.
You said that my 9 was wrong.
The only thing I can think of. All right. Need to factor this, and I've added a little something here, but we have to be able to do this. So this really isn't a challenge, folks. We've got to know how to do this. So this is a trinomial. I gave you a hint and said you are not factoring by the greatest common factor method. Even if you tried to pull out a greatest common factor, there's not one. There is no greatest common factor in these three terms. Okay? So for the trinomial method, I'm going to set up a 2 by 2 box. And y'all might want to be doing this with me in case this pops up. I'm going to set up an X. My first term goes in the first slots. My last term goes in the last slot. I multiply the two together. I get a 30. What goes under here? What goes in the bottom? The middle, 17. Okay. Here is the strange thing. Okay, you guys are not used to the y being there. And we know that the x squared breaks down into x and x. Well, y'all know there's a y squared. How do you think that breaks down? If x squared breaks down into x and x, y squared breaks down into y and y. So you had to have an xy in those boxes. Okay, now I need my magic numbers that multiply to get me to 30, but add to 17. 15 and 2. So I'm going to go ahead and pop those in here. Okay. So now greatest common factor across here is a 1x. Greatest common factor here is a 5y. Greatest common factor here is 3, and there's an x in both of them. And greatest common factor here is 2, and there's a y in both of them. So my factored form has x and 5y in one parenthesis, and 3x and 2y in the other, and I look back at my magic numbers, and they're both positive. And so the one of these two factors that's in my answer choice would be B. Question there? Okay, so this next one is pretty important because we're trying to get somewhere with it. What we're trying to get to is being able to find the area of a composite figure. Composite means it's not just a rectangle, or it's not just a triangle. It's like two shapes put together. So we want to be able to find the area of this. Well, in order to do that, y'all, there's going to be missing sides that we're going to need to find, okay? And so the first thing I want to do is practice finding the missing sides, okay? So this big horizontal line, AB, okay, it goes with two more horizontal lines. In other words, it's parallel to this guy and this guy. All three of these are parallel. So y'all, if you think about it, if I was to take this line and push it up to here, if I take this line and push it up to here, we would have two of the same lines. So when I take this line and push it up to here, this is 5x plus 10. And notice I need the missing piece. Together, these are supposed to make up this piece. So 5x plus something is going to give me 7x. So what is the missing part there? I've got 5x. I need 2x, because when I put them together, that gives me 7x. So I need 2x. And now notice, in order for these two lines to match, I've got 10, but I need 12. So what's missing? A positive 2. So line FE is equivalent to 2x plus 2. Notice when these two lines are put together, they're equal to this line. Okay? Okay, so now it works the same for the vertical lines. So I've got a long line here, that's BC. And then I've got the two pieces that come together to give me the big line. These are all vertical lines. Okay, so if I imagine taking this line and pushing it to here, I would have two of the same lines. So I'm going to take this line and I'm going to push it up to here. So this piece here is 3x plus 1. And now notice these two added together gives me this one. So if this has a 3x and I need to get to 10x, what part is missing for this?
7.
I need 7x, because 3x plus 7x gives me the 10x. And now when you look at the constants, the long line has a constant of 3. I've got a 1, so what else do I need? I need a 2. So now notice when I combine these two lines together, it equals the big line. 3x and 7x gives me 10x. 1 and 2 gives me 3. So this is the expression for the missing side ED. It is 7x plus 2. The other way to do it is by subtracting. I know some of y'all can eyeball it, but some of y'all, you're not good at eyeball it. The other way to do is by subtracting. So here I've got the big line, so that would be 7x plus 12. And if I subtract out the smaller line, it gives me the missing part. So I'm going to subtract out 5x plus 10. So if I distribute this negative 1, I've got 7x plus 12, and then distribute the negative 1, I get minus 5x minus 10. Now notice when I combine, 7x minus 5x is 2x, 12 minus 10 is 2, so notice that works as well. All right? We good? Yeah? Okie dokie. All right. Okay, so I factored x squared minus 49. My factored form is x plus 7, x minus 7. Now, I'm not going to say a thing. I'm going to give you one and see if you can do it. All right. Now I want you guys to factor x squared minus 25. My sign's up there. Look at yours. There you go. Look at my sign and look at yours. All right. Okay, so you guys got it. We've got two parentheses. One of them's going to have a plus in it. One's going to have a minus. X squared breaks down into x and x. It goes in the front. 25 breaks down into 5 times 5. It goes in the back. Okay, factored form, standard form. Factored form, standard form. These are equivalent. They're written in different forms. This is standard form. That's factored form. Okay? Okay, now, you don't need to write this, but I want to show you why this works. Okay, so what I want to do is I want to go back to when you guys were multiplying. So, forget that you've got that up there. Okay? A couple of weeks ago, I'd give you this and I'd say multiply. And you're like, okay, that's a 2 by 2 box. Now, I don't want y'all to do this. I just want you to watch. Y'all would say, okay, I'm going to multiply this by a 2 by 2 box. So x and 5 would go across the top. X and negative 5 goes down the side. So when I multiply here, I get x squared. Here I get positive 5x. Here I get negative 5x. And here I get negative 25. What happens to the middle terms here when I combine them? They cancel out. And I'm left with x squared minus 25. Notice, that's where I came from. Okay? All right. All right. Another one for you. C squared minus 9. Need you to factor that. Yep. Okay. So we got C's in the first slots, 3's in the last slots. One sign is a plus and one is a minus, and it doesn't matter which one is which. Okay? Okay, y'all, this has a name. This factoring method has a name. And we'll have that written tomorrow. Difference of two squares is the name. Difference of two squares is the name. And what they do is shorten it to the letters D-O-T-S. They call this the dots method. Now, y'all, this is what you've got to have in order to factor this. You have to have a difference, got to be a minus sign. You have to have two terms, and both of them have to be perfect squares. Okay, what are perfect squares? It's squares that can be broken down into factors that are exactly the same. So, for instance, 3 times 3. That's why 9 is a perfect square, because 3 times 3 gives me 9. It can be broke down into the same numbers for factors. C squared breaks down into C times C. C squared is a perfect square. This method only works if you have a difference and you have two terms, difference of 2, and those two terms are perfect squares. That's when this method works. Okay? Okay. Let's do a harder one. Yeah, you can pop it under that bucket. I stepped it up a notch, folks. Okay, so the front term breaks down into 3A times 3A. That goes in the front slots. Oh. Front term breaks down into 3A times 3A. That goes in the front slots. Last term breaks down into 5B and 5B, and that goes in the last slots. One sign plus, one sign minus. How'd y'all do? Okay? All right? Step it up a notch. Okay, y'all ready? All right. 7x to the third times 7x to the third. Shh. 7x to the third times 7x to the third is how this breaks down. Remember, y'all, when we are multiplying variables, we add the powers. So that's why it's x to the third and x to the third. So that goes in the front slots of each parenthesis. Okay? The last term breaks down into 6y to the fifth times 6y to the fifth. And that goes in the last slots. One sign plus, one sign minus. Easy? Yep. Okay, I'm going to put in one that's supposed to be easy, and you would be amazed at how many people are going to get this messed up. 100x to the 12th minus 1. Factor that. Okay, so you're finding a square root. Y'all, the square root button is right here in yellow. If you find the square root button, it's right here in yellow. So do second square root. You can see your little square root symbol and type in 100. Now, y'all, it doesn't work for variables, but notice there's your root. It's 10. So you can use your square root button to find your root. That's what it is. It's a square root. Okay, Braylon.
Yeah.
Braylon, come up here.
Okay.
Okay. So the first term breaks down into 10x to the 6 times 10x to the 6, and that goes in the front slots. A lot of people get confused with the 1. Y'all, 1 is a perfect square. It breaks down into 1 times 1. 1 sign plus, 1 sign minus. Are we good there? Just be careful. The easy thing was to put 50 and 50, but y'all, factors aren't adding, they're multiplying. So we needed 10 times 10, okay? All right, one more, we'll call it a wing dinger. All right. Okay, so folks, if you cannot think of the roots for 121, you can use your square root button. So press second square root and put 121 in there. 11 is the root, 11 times 11. So 11 goes in the front slots, and then we're taking half of these, so it's going to be x squared, y to the third, z. Okay, last slots, 144 breaks down into 12 times 12, and then we would have w to the fifth. Okay, all right, keep in mind, folks, you've got to have a bunch of stuff here. Y'all, you've got to have a difference. If this is a plus sign, and they will test you on this, y'all, this is not how to factor it. It cannot be factored. Y'all, if that is a plus sign, it cannot be factored. You can look to factor it by greatest common factor, but by difference of two squares, it cannot be factored. That's got to be a minus sign. Y'all, if any of these powers is odd, if any of these powers are odd, you cannot factor this in this method. It will not work. You've got to have even powers, and you've got to have perfect square coefficients. And it's got to be a minus sign. If any of this other stuff is off, it will not work. Okay? Okie dokie. Let's do our last factoring method. Okay, last factoring method is factoring 4 terms. And again, we'll have this in your notes tomorrow, so you don't have to put it in your notes. It's actually got a name. It's called grouping. Okay, I'm going to demonstrate one, and then I'm going to let you guys do a few of these. Okay? So we're going to factor 4 terms using grouping. First of all, you got to have 4 terms, y'all. 1, 2, 3, 4. Terms are separated by addition and subtraction. Okay, so what we do is we group 2 and 2. We group 2 of them together. Now, just to get started, I've grouped them together already. So basically what we're going to do is take the first 2 and we're going to factor by the greatest common factor method. Notice I'm just going to split this down the middle. So we're going to factor this by the greatest common factor method. So what is the greatest common factor here? 5 what? 5n squared. So I'm going to pull out 5n squared. Y'all do this with me, and I'm going to set up a parenthesis. And now I need to fill in the parenthesis, so I divide both terms by my greatest common factor. Okay, so what do I get in the first part of the parenthesis when I divide here? 1 what? 1n. Okay? What do I get in the second part? Plus 2. We're dividing. Okay? All right, now I've got these last 2. So I'm going to do the same thing. I'm going to factor them by the greatest common factor method. So what is the greatest common factor of these 2 terms? It's a 3. It's a positive 3. So I'm just going to write plus 3. I'm going to set up a parenthesis. And when I divide by my greatest common factor, what do I get? N plus 2. Okay. Now, I have a greatest common factor on this line. Between these 2 terms, there is something in common. What factor is in common in these 2 terms? In common means the same. What's the same from here and here? The n plus 2. So y'all, I'm going to pull out the n plus 2 as a common factor, and when I pull it out, what's left is my other factor, 5n squared plus 3. So that's how you factor by grouping. So let me say again what I did. I grouped 2 and 2. I found the greatest common I factored by greatest common factor method. Then I factored by the greatest common factor method. Then I had a common factor. So I pulled out the common factor, and what was remaining was my other factor. So greatest common factor method, and technically, y'all, this is greatest common factor method. The common factor was n plus 2. I pulled it out, and I have 5n squared plus 3 left. Okay? All right, so I'm going to leave that there, and I'm going to let you guys try one. All right. So I can help get you started. We're grouping 2 and 2. So ignore the last 2, find your greatest common factor, do your greatest common factor method. Then go to the last 2 and find your greatest common factor method. So I want to see how far y'all can get without me. And now I'm going to divide by my greatest common factor. So when I divide here, what goes in the first slot? 2p. And when I divide here, what goes in the last slot? Plus 5. Okay? All right, now I'm going to ignore this, and I'm going to factor this by the greatest common factor. What's my greatest common factor here? Plus 3. I'm going to set up a parenthesis. What goes in the first slot? 2p. What goes in the last slot? And now notice, I've got a common factor. It's 2p plus 5. So I'm going to pull out 2p plus 5, and I'm left with p squared plus 3 as my other factor. Factor in 4 terms by grouping. Okay? All right, y'all try this one. Okay, in this first set of 2, what's my greatest common factor? It is x squared. So when I divide by my greatest common factor, what goes in my parenthesis? X plus 4. Okay. Okay, in my second pair, what's my greatest common factor? It's a 5. It's a positive 5. I'm going to set up a parenthesis and divide by my greatest common factor. So what do I get? X plus 4 again. And now I have a common factor, x plus 4. And my other factor is x squared plus 5. Last one. All right. All right, so I'm going to do greatest common factor on the first 2 terms. The greatest common factor is 2x squared. So when I factor by the greatest common factor method, when I do the division here, I get a 2x, and here I get a positive 1. Factor these by the greatest common factor, which would be a positive 9. Set up a parenthesis. When I divide by my greatest common factor, I get a 2x plus 1. Now 2x plus 1 is a common factor. And then the remaining factor is 2x squared plus 9. How'd you do?